Okay. Ozonolysis in organic compound. Basically, this is a technique. What is the purpose? To establish the position of pi bond on carbon skeleton. This is the real concept. In organic chemistry, ozonolysis has two aspects. One is from a structural point of view, a structural analysis point of view, and second is mechanism of ozonolysis. Right now, I am not going to discuss the mechanism. I am discussing here the concept of ozonolysis, how to use the ozonolysis for the establishing the position of pi bond in carbon skeleton. See, point number one, what is ozone? Is equal to O3, and this is the ozone. Or we can also write in this form. See here. What is happening here, or somewhat very high energy species will be like this. It is not possible nearly impossible. Reason, oxygen can't have incomplete octet. See the concept. O3. What is the basic of O3? We have O2. There are two oxygen atoms, each having complete octet. See. Anyhow, if some third oxygen comes here with incomplete octet and demanding somewhat electron, just give me incomplete octet. In that very case, just a temporary arrangement is made by donating this pair of electron to this oxygen. See this. Technically, O2 is stable. They are sharing 4 electrons. They have complete octet. But by the way, if some other oxygen atom comes here without octet, complete octet, with incomplete octet, then what happens? Any atom, since it has lone pair, it will donate to it. But that very donation is not very fruitful. Reason, oxygen can't bear positive charge. Oxygen do not want to share this electron. Oxygen itself is highly electronegative. Oxygen itself is highly electronegative. But this is the compulsion. This is the temporary arrangement. Ozone is just a temporary arrangement. Ozone is unstable. And you see, I consider this ozone as a team of wolves. They are just like tigers, lions, whatever it may be. Out of 3 atoms, 1 is not satisfied, other 2 has complete octet, but the third atom is under compulsion. It do not have complete octet. It is just how a temporary arrangement. This oxygen sharing its own electron, but it is not very pleased and stable. What this mean? I often call this ozone as thief of electron. Mind my word, thief of electrons. They are a team of thieves. They are in search of electrons. Reason, their octet is not complete. They are doing all maneuvering, donating themselves, exchanging themselves, but they are not at all stable. This is the basics of ozone. Ozone is a strong oxidizing agent. What makes this? Ozone is a strong oxidizing agent. Now the next concept is, when ozone gas comes in contact a pi bond, pi bond means electron rich. A species, it undergoes reaction. See, think this way. We have a team of thieves, and when they see a rich person, anyone, simple example, ethylene. This ethylene has sigma bond as well as pi bond. The pi bond is exposed. Electron rich. See, now this is the beggar and this is the rich person. Whenever they see this, they try to snatch their electron. How? That is mechanism. For the time being, just consider this. This is developing a positive charge. Therefore, the pi electron goes first to here, and as soon as this get electron deficient, the second species attack this. This takes place simultaneously. What this means? This CH2, they dissociate the first bond and form this species called mono-ozonoid. Again, it is not very stable. The thieves anyhow broke into the house to steal the pi electron. This is electron deficient, this has positive charge. They start collecting the electron, pi electron. And since you know, whenever one bond is given, basically it is forming a bond from here. Therefore, this atom will develop a positive charge. And the positive charge is further compensated by the negative charge of the oxygen atom. And here we got a mono-ozonoid. Whatever may be the compound, this is the pattern. In this pattern, they start reaction. Whenever they see a pi electron, they start in this fashion. Let us see what this means. Suppose we have O3 and we have a cyclohexene. So what will happen? They attack here, 1, 2, 3, and the pi bond get dissociated, 1, 2, 3. See, 1, 2, 3. This is called mono-ozonoid. See, these are the team of thieves. And this is the wealthy person. They first broke the pi bond. Now the problem is, the atom number 1 is getting electron, 3 is getting electron, but 2 is not getting electron. They have looted 2 pi electrons. One is stolen by O3, one is stolen by 1, but not by 2. Therefore, they maneuver further and try to loot further electrons by rearrangement, and they will form ozonoid. This is a rearrangement reaction. I am not going into that very rearrangement reaction, that is called Craigie rearrangement. And you are getting, this is called ozonoid. Now the simple approach, whenever we have a pi bond and whenever we have ozone, we should dissociate 2 bonds. Pi first, followed by sigma. And what will happen? They get inserted inside the bond, and this is called ozonoid. In the same manner, suppose I have butadiene, butene, then what will happen? The idea is simple. The 3 thieves, 2 bonds, pi and sigma, they dissociate these bonds, pi first, sigma later on, and they will form ozonoid. In this way, 2 atoms on one side, 1 atom on other side. In the same way, if we have somewhat more complicated structure, then no matters. They will form in the same manner, 1, 2, just try to see this. Any doubt? Example 1, example 2, example 3, example 4. How they are making the ozonoid. How to make the ozonoid? The idea is simple. 3 thieves, and here we have 2 bonds. Which bond? Why not this bond? Because this will not dissociate, it is sigma, and the pi, it will dissociate from pi. Pi first. No one is going to dissociate or break the boundary. They are looking after the gate. The pi is the gate. Once they have broken into the pi, then after they will dissociate the sigma further. And they will form ozonoid. Now the technique number 1 is how to form ozonoid. How to form ozonoid, not the mono-ozonoid. I have introduced the concept of mono-ozonoid just to make it easy to understand you. Otherwise it is very simple. How to form ozonoid. Now the concept is, point number 1, all carbon-carbon pi bonds, all carbon-carbon double bond and carbon-carbon triple bonds are attacked by ozone. All alkenes are attacked by ozone. This implies alkene, this implies alkynes. All alkenes, whatever they may be. Here we are not talking about stoichiometry, that I am taking 1 mole of ozone, 2 mole of ozone. No, sorry. I am taking excess of ozone. In all these reactions, suppose you have this compound. 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 The idea is simple. Locate the pi bond and locate the reagent. In all these reactions, the reaction starts with ozone. Organic chemistry, whether it is 1 or 2 or 3, it hardly matters. We have to attack here, we have to attack here, we have to attack here as well as here. And in this case, we have to attack all the 3. And now the product is very simple. The product is, in all these cases, we have to dissociate this bond. See, in this very case, I will dissociate this bond. Suppose. In this very case, I will dissociate this bond. In this very case, I will dissociate this bond and also this bond. In this very case, I will dissociate 1, 2, 3, 4, 5. This bond, then after this bond, and then after this bond. And what to do next? Just add oxygen, one on one side, two other on other side. This is the technique. It is simple technical question. How to write ozonoid? See, in this way, I will write the product of ozonoid product. Okay, any doubt? Hello, Sudhin? Any doubt? Okay. Sudhir?
No, sir.
No doubt. Okay. Now see, this is step number 1. This is the reagent number 1. What the ozone will do? Ozone will do this. Now we have a step 2. What is the step 2? See, ozonoid once formed is followed by hydrolysis. There are two types of hydrolysis. Reductive hydrolysis and oxidative hydrolysis. See, how do I know that the reaction is reductive or oxidative? It is all because of reagent. It is all because of reagent. In reductive hydrolysis, the reagent used is zinc followed by water. Sometime ammonium hydrosulfide, this or ammonium sulfide. In oxidative hydrolysis, the reagent is simply H2O, H2O2 or H2O. See this. What I mean, all organic reactions are detected by the reagents. If someone is writing ozone, zinc, water, this implies he is talking about reductive ozonolysis. If someone is talking about ozone H2O2, then he is talking about oxidative ozonolysis. See, till now I have discussed the role of ozone, how ozone form ozonoid, and now after I am discussing the third part, the hydrolysis. This hydrolysis is further of two types, reductive and ozonolysis, reductive and oxidative. Just take it lightly, it is not a tough task. How? Let me explain you. Ozone, they are the thieves. Zinc water, they are the police. What this means? Once we have see this. In this case, what you are talking about? Ozone, zinc water. This is the thieves, the team of thieves, and they are the police. What they do? Zinc or H2O2. Oxidative ozonolysis. What they do? Zinc, they are the thieves. And they are the supporter of thieves. Think in this way. In one case, the same compound, in the other case, the same compound. In both cases, ozone will attack. The thieves will attack. The thieves form ozonoid. See the story. This is very interesting story. Already, the thieves are inside the house. Now what? Now, if zinc is there, zinc is reducing agent, zinc is just like a police person who snatch out the third person. This is removed by zinc, a zinc oxide, and the product is, and both of these oxygen will go inside the house and form a double bond, and this is your product. This is the ozonolysis product. What will happen here? If the thieves are there, police will not come, rather their supporters will come. Then what will happen? In that very case, the rare case, the other thing is, they will form a double bond and these supporters will kidnap the babies of the house and will form carboxylic acids. See, that is the difference. In this way, we can write the product. The writing product, how to write the product? The very simple. Writing product is very simple. We have to memorize ozone, zinc, water, thieves enter the house, police came, one going to jail, the two remaining will sneak into the house with double bonds because they have two valency. What happens if police will not come? If their supporters will come, then something different will happen. They will snatch the everything what they have and even kidnap the younger boys of the house. See, in this way they will form carboxylic acids. Now this product formation depends on whether we have H or not. If H is there, they will be replaced by OH. What this means? Double bond is replaced by double bond O on both the sides, and if they have H, and condition is if they have H and if zinc is not there, then H is replaced by OH. H of double bond is replaced by OH. If zinc is not, zinc or ammonium sulfide is not there. This is the reductive ozonolysis. Oxidative ozonolysis. This is called oxidative ozonolysis. This is called reductive ozonolysis. How to see reductive and oxidative? This is the technique. Now we are going to apply these techniques on different atoms. Okay, let us see some more examples. Now direct coming to the examples. Suppose we have propene. First we will see how many hydrogen atoms is there. This is equal to CH3, CH, double bond, 2 hydrogen. If someone write ozone, zinc, water, then we must memorize that the police has arrived on the scene after the loot. And the product is CH3, CH double bond O plus O double bond CH2. Formaldehyde as well as esteraldehyde. But what will happen if we have ozone followed by water, H2O2? This is reductive, this is oxidative. How can I know zinc is not there? In that very case, in addition to the pi bonds, these boys will also be kidnapped. And each hydrogen is replaced by one OH. What this mean? CH3, CHO, this is nothing but acetic acid plus carbon double bond O and 2 OH. This is nothing but carbonic acid or CO2 plus water. See, we have two different products in reductive and in oxidative. Okay. Let us see some more examples. Suppose I have this compound. Ozone, zinc, water. Just dissociate this bond and add oxygen. Dissociate this bond and add oxygen. No. Out of 3 atoms, 2 atoms will go to the product and 1 goes to the zinc. And if we have ozone, H2O2, then look after the any baby in the house. This will also be kidnapped. Now the answer is acetic acid plus acetone. Here we do not have any baby, therefore it can't be kidnapped. See, in this way, we can write the product. Whatever may be the reaction, how to write the product? This way. Whenever we have branching, all branch goes to ketone, unbranch goes to aldehyde, and inoxidative carboxylic acids. This is the technique. Reductive ozonolysis, of alkene, the product is aldehyde, unbranched area, and ketone. Oxidative ozonolysis, of alkene, product is, see, here the aldehyde get converted to carboxylic acid. Sometimes you also get formic acids, or basically H2CO3, that is nothing but CO2 and ketones. In this way, we can write the product of ozonolysis of alkene. I have not discussed the alkyne. Right now I have discussed the alkene. How to see? They are the thieves, this is the police person, the thieves, and we do not have, they are the supporters of thieves. They kidnap even the baby, if present. They can't kidnap the carbon-carbon bond. That is the technique. In this way, we can write the product of ozonolysis. Let us see some examples, more examples. Suppose cyclohexene, see, 1-methyl cyclohexene, ozone, zinc, water. Zinc is there, this baby will not be kidnapped. The police person has arrived, but this will go. And the answer is this one and this one. But if zinc is not there, then what will happen? The baby will also be kidnapped. This is called reactive ozonolysis. This is called oxidative ozonolysis. Any doubt? Sudhir? Any doubt? Did you got the concept?
Yes, sir.
See, now I am going to discuss just in brief the oxidation, the ozonolysis of alkynes. The same formula is here, the same concept. Ozonolysis of alkyne. You can go for the details in chapter alkene. Everywhere in any chapter of alkene, you will get a number of questions on alkene and alkyne also. In case of alkyne, suppose I have this alkyne. With ozone, the same funda takes place. The thieves will sneak into the house and rearrange like this. But the difference is, out of 3 bonds, 1 bond will remain. The 3 thieves, they stole 4 electrons, not the 5th. This is your ozonoid of alkyne. Now 2 things takes place. Same manner, zinc water, zinc is there, this will be jailed, and the remaining 2 will sneak inside the house. But now the house is not apart. It will form a diketone. Though unstable, but diketone. What will happen if zinc is not there? If H2O2 is there? In that very case, they will snatch the electrons of the sigma bond also. See. And I have already given you the simple concept. For every bond, just write 1 OH. For every bond, just write 1 OH. How many OH? 1, 2, 3. 3 OH means carboxylic acids. How many OH? 1, 2, 3. 3 OH means carboxylic acids. The answer is acids. Alkyne gives acids. Alkyne never gives aldehydes or or ketones, because branching is not there in aldehyde. They will never give ketone. See, and H is also not there. They have 2 pi bond and 1 sigma bond. First the 2 pi bonds will dissociate, and finally the sigma bond may dissociate in case of oxidative ozonolysis, but not in case of reductive ozonolysis. This is the whole approach of ozonolysis. But the problem solving is different. But the problem solving is somewhat different. See, problem solving of ozonolysis is somewhat different. This is not so simple. Okay. Any doubt? No doubt. Let us go for problem solving. Okay. Just wait for 1 minute. Then after I will go for problem solving.